Let's get ready for some schoolwork. All right. Coffee. I'll take care of you. Winner, I got your back. All right. So, friends, I'm on page 177. You still following me on this adventure? All right. So, page 177. In the United States, the average height of an adult male is 69 inches. Hey, that's how tall I am. Perfect. Well, the standard deviation of 2.5. Okay. All right. All right. So, yeah. Oh, thank you. So our average is 69 inches. Still with me? So if my standard deviation is set to be 2.5 inches, that means if I go out, if I add 2.5, so that's 71.5. If I add another standard deviation, add, what is that, 74? And then add one more standard deviation. That's going to take us to 76.5. Still with me? Perkins, remind me to mark you unabsent. All right. Let's see. 67, 66.5. 64. And 61.5. I think I did my math right. Okay. So that's our normal curve with the average height on page 177. Number one says complete the bell curve with all 7 positions. Okay, so then a few things that we want to put in place. We know that this is 0.15%, and this over here is 0.15%. Okay. And I have a sneeze that wants to come out, but it's not coming yet. I feel blessed. And then as I progress through this, so friends, this is definitely good stuff to make sure you have these on your half sheet for the quiz tomorrow. Again, if you're here tomorrow, you get to do the quiz together as a class. If you're not here tomorrow, you have to do it individually. If you're here tomorrow, we have a quiz, so I'm being that teacher. But if you're here tomorrow, the reward for being here tomorrow, you get to do it as a class. All together, meaning I grade 1. If you're well, you'll all put your names on your individual one, then I'll figure y'all got the 15 out of 15 because, and then those who aren't here. Cool. All right, so let's take a look. All right, problem number 2. So what percent of males are 74 inches and above, taller than 74? So here's my 74, agree? So all I do is I go 2.35 plus 0.15. So that gives us 2.5% of males are above 74 inches tall. Okay, so I was just going this way. That's pretty simple, yes? Problem number 3. Problem number 3 says, what percent are shorter than 66.5 inches? Below. Okay, so that's this guy. So I'm going to add this, this, and this up. So this plus this is 2.5. 14, that's 16. That would be 16% of the population is below 66.5 in height as far as this male population of the U.S. Okay? And then problem number 4 says, hey, what percent's between 64 inches tall and 74 inches tall? So 64 to 74. So we're talking about this region here. Agree? So 13.5 plus 13.5 is 27. So that's 27 plus 68. So that's 5, carry the 1. So that's 7. That's 95% of the population of these males are between 64 inches and 74. Yeah. Yeah, so that is for the normal curve. That is exactly right. So if you wanted to ever find the exact percent, the 34% are like 33.972 or something like that. But they just round them all just to make it a simpler thing. Okay? And that's how we can also tell if it's normal curve, because between the first standard deviation should be 68%, but let's say you had 78 people in there. That right there tells you don't have a normal curve. It's possible that it's skew right or skew left. Okay, so that's just one of the things, and I think we'll see that kind of question here in a moment. And then problem number 5. What percent of U.S. adults are taller than 76.5 inches? So 76.5 is here. We're going that way. So we're talking about 0.15% are 76.5 or taller. Okay. This kind of makes sense. It seems simple to me, but also I know it's the first time you see it. So you're just reading off of this. As of right now, we are falling exactly on standard deviations in order to find it. There'll be other ways that we'll find using Desmos called normal CDF that will allow us to find other stuff. All right, let's do, ooh, that's a fun green. Number 6. Number 6. If Nathan is taller, I'm changing that 86 to 84. Okay. If Nathan is taller, so I'm changing number 6 to 84, not 86. If Nathan is 84% taller than everybody, we have to figure out kind of where 84 is going to fit. So the entire population is 100%. Agree? All right, so we're going to have to start docking some numbers. So I'm going to probably dock 2.35% and 0.15%. I'm just subtracting those till I get to 84. So that's going to take me to 96.5. Okay, not quite there yet. Let's subtract the 13.5. Let's see. If I subtract those at 0.383. Oh. So I either made an error someplace in my subtracting or I didn't. 2.5 minus 100. Oh, that should have been 97.5. Sorry. And that would give me an 84. So that means that our person is taller, is 71.5 inches or taller in height. Okay. So I was just taking away the portions until I got to the 84. So I had to change number 6, went from 86 to 84%. That was an error. All right, problem number 7 says IQ tests are normally distributed with a mean of 100 and a standard deviation of 15. Okay, we want to make our normal curve. Okay, they tell us it's a normal curve, so we trust them. So they tell us that 100 is the normal, then 115, 130, 145. Does everyone feel comfortable how I just got those? Because we know the standard deviation is 15. So then if I go the other way, this is 85, this is 70, and this is 55. Okay, not 55%, 55 IQ. Okay, and that's a real thing. Okay, we could go and plug in our percents. We have 34% here, 34% here, 13.5% here, 13.5% here, and 2.35% and 2.35%. And then the last is the 0.15%. So a small little percent. Okay. What percent of IQs are greater than 145? So 145 is here, so we want greater. So what do you think? 0.15, good. And you know what? This class is an anomaly. You want to know why? Because you all have an IQ greater than 145. We're all at the genius level in this class. Well, except for this guy. I'm like at 70. All right, number 9. What percent are between 85 and 115? So we're going between these two guys. So what percent is that? What's the area between these guys? Whoa, close. 34 plus 34 is 68. Nope, because it was just between those two. So 85 to 115 is one standard deviation. So you're talking about 68% of the population falls within one standard deviation. And then if you have an IQ that is one standard deviation above, so one standard deviation above, what is your IQ? Oh, wait. Below. I'm sorry. One standard deviation below is this guy. So you have an 85% or IQ. Okay? Am I doing okay?
Yeah.
Okay. Thanks, guys. So we have the data that's given to us. I need to jump onto our buddy Desmos. Can I have a volunteer once I'm ready read me those scores? Not yet, though. Not yet. Still not yet. Still not yet. Our buddy Desmos. DESMOS. Calculator. Plus table. Okay, someone read me those. Gotcha. Oh, hang on. 16.3? Okay. 14.9. Ooh, 2.5. Yikes. 19.3. 7.6. 11.2. 28.4. 15.3. 17.2. 9.0. 15.2. 14.9. 11.6. 12.5. 15.2. 8.5. 16.3. 17.3. 10.6. 11.5. and 15.2. All right, so once you have the data in, what you want to do is go down to the next number line and bring up your keypad, go into functions under stats. So we want to find the mean of x1. Go down to the next one. We want to find the median of x1. And we want to find the standard deviation. Okay, so use your calculator to find the mean. So we have 13.9 as the mean. We have a standard deviation of 5.1. Okay, now what up here on our list would indicate that we don't necessarily have a normal distribution? What two things will dictate to you if we have normal distribution or not? Those are equal signs. I'm sorry.
Oh.
Yeah. Yeah, the mean and the median, they are not the same number. Agreed? This is slightly skew left. That doesn't mean we can't make predictions off of it, but we now know, because if you look at your information, it is slightly skew left. Okay? What we could do, we could type in histogram. Hey, Alex. Histogram of X1. And so if we take a look at our data, can you see how that would somewhat be skew left? It looks like it's pulling to the right, but what's basically happening is our median is here at the 15.5, and our mean is about here. Okay? Some people might say, well, that's going to make it skew right. Well, we have more data this way, so the more data this way, even though it's not quite as far out, is still pulling it to the left. That's what's telling us that we have it skew left, because the mean is a smaller amount than the median. Okay? What percent of the data will lie within one standard deviation of the mean? Okay, so on number 13, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 22 pieces of data. Okay? So what percent lie within one standard deviation? So our standard deviation, let's see, our mean was, let's take our mean to 14 and our standard deviation to 5. Okay, so what percent lie within one standard deviation? So I'm looking from scores from 9 to 19. So you'd go and you'd take a look at your data. That would give you 70 or 17 pieces of data would lie within one standard deviation, which is 77%. So that 77%, what percent should lie within one standard deviation? What percent should lie within one standard deviation of our mean on our normal curve? 68. It's 77. So what can you tell me? This is not normally distributed, also because of the information out there. What percent of the data lie within 2 standard deviations of the mean? So then we're looking to go, we have our number 14. We have our mean of 14, and we're looking basically 2 standard deviations, so plus or minus 10. So we're looking at data from 4 to 24. And if we counted that up from our data, it looks like we'd have 20 out of 22, which is 90.9%. So if we look back at our graph, within one standard deviation, you should be talking about 95%. So you're going from here to here. So that should be 95%. And notice we are at 90.9. So again, that's indicating that we don't have a normal distribution. And then what percent of the standard deviations would be within 3 or how much data would be within 3 standard deviations? So we still have our average being 14. Our 3 standard deviations, we're going plus or minus 15. So we're going from -1 to 29. And that would be all of our data, 22 out of 22, which is 100%. And again, within 3 standard deviations, you should be at 99.7%, and we're at 100%. So again, it's showing us. And then from the information above, do we judge our data represents normal distribution? No. We have a few things. We have our mean is less than our median. That's one indicator. And then also the answers for 13, 14, and 15, those do not fit within the averages, the percents that we put up there, okay? So that's kind of key to know about that. All right? So, my friends, for today, I would like you to work on page 179 and 180, Okay? We do have a quiz tomorrow, which is Tuesday. And what is the gift I'm giving you? If here, work together. If you miss, on your own. Cool? That deal? Save.